As of yesterday, Kimi K3 is openly downloadable. It's roughly 1.5 terabytes, which is larger than most people's entire computer. And yet, this week, someone got Kimi K3 running on a GPU-less mini Mac, and someone else got it answering on a 64 gig MacBook. So what's going on here? Did the 2.8 trillion parameter model just change? Does it no longer need to only be deployed in a data center? Or did people find a way to technically run it while making it almost useless? That's the mystery, and the answer matters even if you never plan on running Kimi K3 locally, because it tells us who's going to actually get to control frontier AI next. Welcome back to Wadood AI. I'm Wadood. I'm a senior product manager working on AI experiences, and a lot of my work focuses on customer-driven evaluations, basically the gap between an AI demo and the AI system that people can actually trust in production. The more important story, in my opinion, is that Moonshot has released the weights for a frontier-level model that other companies can host, inspect, optimize, and build around. But there is a catch. Open weights do not mean easy access. The checkpoint itself is about 1.56 terabytes across roughly 96 shards. Community estimates are putting serious full model serving at around 1.5 TB of fast GPU memory. That's roughly the scale of 18 H100 class GPUs or several GB200 class systems. So how did those ordinary machines actually produce answers? In a few minutes, I'll show you the trick. But first, you need to understand why the obvious answer, 104 billion active parameters, is not enough. Then we'll look at what actually moved through the SSD, what took so long, and why this could still be one of the most bullish open weight releases we have seen. Because the real question is not, can I download Kimi 3? It is, who can turn this download into useful infrastructure? So let's get into it. Most of the Kimi K3 conversation has focused on the obvious question. Does it beat Claude Fable 5, GPT 5.6, or any of the other frontier models? And that is a super reasonable question, but it is also the most crowded version of the story. There are already plenty of benchmark tables and reaction videos and people putting head-to-head prompts. Kimi may compete strongly with the closed frontier models in a lot of different areas, but I would not tell you that it is automatically the best model overall. The benchmarks use different harnesses, different tools, and different evaluation setups. The more important question is what happens when a model this capable becomes something other people can host, inspect, optimize, and build around. And the hardware problem is what makes this shift somewhat easy to miss. The first mistake is treating 2.8 trillion parameters like it's a simple horsepower number. Kimi K3 is a mixture of experts model. Think of the total model as a huge company with hundreds of specialized departments. For every single token, the routing system does not ask every single department at once. It selects the expert that's needed for that particular step. That is why Moonshot can describe 2.8 trillion parameters while listing about 104 billion activated parameters per token. The active number tells you roughly how much of the model is doing the immediate computation, but it does not mean that the rest of the model just disappears. The full warehouse still has to exist somewhere. The router still has to find the right experts. The system still has to move the weights through memory fast enough to keep producing tokens. And this is where the numbers start getting confusing. Total parameters describe the full capacity of the model. Active parameters describe the amount of expert capacity used for a particular token. So storage is describing how much disk space is used to keep the checkpoint. And then VRAM describes how much fast accelerator memory that you're going to have available for weights, caches, and all that other stuff. And compute describes the actual mathematical work. Right? These aren't just going to be interchangeable numbers. Moonshot's official Hugging Face repo shows the released MX FP4 checkpoint at about 1.56 terabytes across roughly 96 shards. That is literally and figuratively the warehouse. The community estimate of around 1.4 terabytes of VRAM is a different question. How much fast memory might be needed to serve the full model in a useful configuration? And that figure is an estimate, not an official Moonshot requirement. It changes depending on quantization, context length, batching, serving software, and how much headroom you're going to need. But it gives you the right order of magnitude. An ordinary gaming GPU is not going to hold this model. Even a powerful workstation may be nowhere close. And that is before you ask whether it can serve multiple users with reasonable latency. The obvious conclusion would be that Kimi K3 is basically irrelevant to normal people. You can download it, but you cannot use it. Except people have started using it anyway. One community project ran Kimi K3 on a GPU-less mini Mac, and it used the system memory and multiple consumer NVMe drives, streaming the routed experts from disk when they were needed. The model loaded, it answered correctly, but the numbers tell the real story. The reported setup took roughly 10 minutes just to load and took around 45 minutes to generate 40 tokens. 40 tokens is like less than a sentence or two. Another experiment used a single 64 gig M1 Max MacBook. After optimizing the runtime, the project reported a median around 4.1 tokens per minute across 6 full model runs. That is genuinely impressive engineering. It is also not really actually reasonable in terms of the amount of time it's taking to serve. At 4 tokens per minute, a response that feels instant from a normal assistant like ChatGPT can literally end up taking minutes. Imagine you ask it, what's the weather today? And then you go and get a coffee and go out for lunch and it's still not done. When someone says, I ran Kimi K3 on my laptop, there are 4 possible meanings to that. It loaded, it answered quickly, and it served multiple users reliably. The experiments prove the first 2. They do not automatically prove the last 2. And that's the part that's so easy to misunderstand. The trick is not that 1.5 terabytes somehow fit inside 64 gigs. The trick is that the runtime does not keep every single expert in the fastest memory at the same time. The full model can sit on storage. The dense parts and frequently used parts can stay in RAM. The routed experts can be loaded on demand, and the system can cache the pieces that it expects to need next time. That makes the model technically runnable, but it also turns inference into a memory movement problem. SSD storage is much slower than RAM, and RAM is much slower than VRAM. And if the processor is waiting for the next expert to arrive, the processor is no longer the bottleneck anymore. The conveyor belt is. And that's why a smaller quantized file does not automatically solve everything. Quantization reduces the weight footprint, but it does not erase routing overhead, synchronization, context memory, or the time required to move the data around. It is also why a 1 million token context window should not be read as you can casually paste 1 million tokens into your laptop. Context length is a capacity claim. Practical serving also depends on cache size, prefill time, memory bandwidth, batching, and the actual latency targets that you have. The difference is the same as owning a huge library and running a busy library. Owning the books is one problem. Finding the right book for the one person is a whole different challenge. And finding books for 1,000 people at the same time is a completely different beast. So if most people are not actually going to self-host the real model, what do the open weights actually change? And this is where I think the Kimi K3 story becomes much more bullish. There are 4 groups that are going to benefit immediately. The first is inference providers. Providers can host Kimi K3 and compete on price, latency, privacy, and reliability. You do not need to buy a rack of GPUs to benefit from that competition. You can access the model through a provider that handles the hardware for you. The second group is enterprise teams. An enterprise can actually evaluate a private deployment, inspect the model's behavior, compare it to other providers, and reduce their dependence on one vendor's roadmap. That does not mean that every single company should suddenly run Kimi K3 internally, but it does mean they now have a serious artifact to test internally if they have the capacity to do so. The third group is going to be researchers and optimization teams. They can work on kernels, they can do the quantization, routing, memory management. It's part of what they've done before. The fourth group is going to be startups and tool builders. They can build products around the model instead of just waiting for a closed lab to expose the exact feature, price, or usage policy that they need. And this is the part that most consumer conversations are completely missing. Open weights do not necessarily mean that every person is going to get a frontier model running underneath their desk. What they mean is that more people can participate in the layer above the model. The hoster can optimize it. The enterprise can evaluate it. The researcher can modify it. And the startup can build around it. And the consumer may eventually even get a cheaper, faster, smaller, or more specialized version because all of those groups are competing to make the model more useful. And that is why I think the headline should not be Kimi K3 beats Claude. The stronger headline is that frontier intelligence is starting to look like infrastructure. And infrastructure does not have to run on every laptop to change the market. Electricity changed the world, even though most people never owned a power plant. The internet changed the world, even though most people never operated a data center. Kimi K3 may be a part of that same transition for AI models. The weights are open, but the useful deployment is still difficult. So what should you do with Kimi K3? Well, if you're a normal laptop user, don't go out and start buying some hardware. Start by asking whether you actually need the capability, whether an inference provider can just give you access to K3, and whether the economics work for your real task. If you're a developer, researcher, enterprise, or startup, the release is a little bit more interesting. You now have an open frontier artifact that other companies can host, optimize, customize, and compete around. If you are watching the AI industry, this is the bigger takeaway. The next competitive advantage may not belong to the lab that trains the largest model. It may belong to whoever makes the model reliable, affordable, private, fast, and useful for a specific workflow. Kimi K3 is open. It is not easy, and that is exactly why it matters. So that's the Kimi K3 story. It's not that the model suddenly puts frontier AI on every single laptop. It may be that the model gives more companies the right to host, test, optimize, and build around frontier level intelligence. If this helped you understand the difference between an open model and a usable model, leave a like and subscribe to A Dude AI. And turn on notifications for the next breakdown. Because the next question is not simply which model won. It's which model can become reliable infrastructure for the work that you actually do. Thanks for watching with Dude AI. I'll see you on the next one. Peace.